The mean cholesterol levels for women aged 45 to 59 in Ghana, Nigeria, and Seychelles is 5.1. I'm not sure what that is, but 5.1, and the standard deviation is 1. Assume that the cholesterol levels are normally distributed. All right, so for A, state the random variables. So this is cholesterol levels. B, find the probability that a woman aged 45 to 59 in Ghana has a cholesterol level above 6.2. All right, so we know we're dealing with a normal distribution. The center of the distribution is at 5.1, standard deviation is 1, and we want to be at 6.2, so that's going to be a little bit out here, more than 1 standard deviation. Let's find our z-score. So it's going to be, 6.2 minus 5.1 divided by 1, which is 1.1 over 1, which is 1.1. So we're going to do a normal distribution. Normal CDF from 1.1 up to infinity, and we get 0.1356. So the probability that our z-score is as big as 1.1 is approximately 0.1357, or 13.5%. Suppose the doctors decided to test a woman's cholesterol level again and average the two values. Find the probability that this woman's mean cholesterol level for the two tests is above 6.2. So they're basically saying here, we're going to be doing an average of size 2. So now, instead of a z-score of 1, right, we have to do our sample average. So our z-score is going to be 6.2 minus 5.1 divided by, 1 over square root of 2. So, what do I have? I've got 6.2 minus 5.1, and then I'm going to divide that by 1 over rad 2, square root 2. There we go. So now we're 1.55 standard deviations, 1.56. So we're going to say, well, what's the probability that our z-score is as big as 1.56? Well, that's going to be approximately from 1.56 up to infinity, and that gives us 0.059, or roughly 6%. Suppose doctors are being very conservative, decide to test a woman's cholesterol level a third time and average the 3 values. Find the probability that this woman's mean cholesterol level for the 3 tests is above 6.2. So again, it's the same problem. So now we're going to go, our z-score is 6.2 minus 5.1 divided by 1 over rad 3. So what do I have? I have 1.1 divided by 1 over the square root of 3. And I get 1.9. So now we're roughly 2 standard deviations away from the mean. So we're going normal CDF from 1.9 up to infinity. And that gives us 0.0287. So the probability that our z-score is as big as 1.9 is approximately 0.0287. And then E, if the sample mean cholesterol level in this woman after 3 tests is above 6.2, what would you conclude? Well, we would conclude that we're fairly confident that her cholesterol level is in fact high and higher than average, because the likelihood that this would have happened by random chance is very small. So therefore, we're fairly confident that she does in fact have high cholesterol. That's it.